Well, good morning to one and all. This is Venkat from Triple Department. Today my topic is about a presentation on the effect of excitation on current and power factor, which is related in synchronous motor. Well, this topic is purely based on the stream of induction and synchronous machines course. Well, today's my agenda is about to explain effect of excitation on current and power factor in the synchronous motor. Well, that is, how does a current and power factor will affect with the excitation method in the stream of synchronous motor. Well, before going to discuss about the effect of excitation, power factor and voltage. First of all, we will discuss about the synchronous motor. So, what do you mean by synchronous motor? Synchronous motor operates at a constant speed and regardless of the load. So here there is the construction of synchronous motor where it represents the bearing in shaft, slip rings, armature winding, rotor, stator, cooling fan, terminals and brushes. So these are the components where we use in synchronous motor. How do you calculate synchronous speed? Ns is equals to 120 F by P. F is nothing but frequency, P is nothing but poles. Yes, synchronous speed. Synchronous speed can be represented can as n suffix s. This is widely used in industrial applications due to their efficiency and understanding current and power factors crucial for optimal performance. So they are widely used in industrial applications due to their efficiency. Efficiency is nothing but output by input. By understanding and by understanding the current and power factor is very crucial for optimal performance. Well, first of all, we have to know about the basics of synchronous motor. Well, what do you mean by motor? What's the working principle of motor? Well, the motor is nothing but where it converts from electrical to mechanical energy. Where it converts from electrical energy to mechanical energy. But whereas coming to generator, it converts from mechanical energy to electrical energy. So there is a lot of difference in working principle in motor and as well as generator too. A synchronous motor which converts electrical energy to mechanical energy. Right? Here there are having two poles, that is North Pole and South Pole. Its rotor rotates its synchronous speed with a stator magnetic field. By observing this by observing these poles which are connected to the brushes, that we can call it as B1 and B2. Here it is connected to ammeter to measure how much current is flowing towards the motor. This synchronization allows for precise speed control and stability. So this is the basic circuit diagram which synchronize which allows the precise speed and control and stability. With importance of current in synchronous motors. So what's the importance in current? Current is very essential for creating the magnetic field in motor. Right? Where there is a magnetic field, we can provide current. If we don't have any magnets and magnetic field, we cannot produce current too. The magnitude of the current which affects the torque produced. Sufficient current is required to overcome the load demands without any overheating. Without overheating. Heating effect we will turn on. Heating effect is also known as the resistance or resistivity like that. So here there is the basic derivation of voltage and power factor. That means which is fully related to the current. Well, From this mathematical representation of current in synchronous motor, we can tell that how much importance is there, how much effort it would be like. Well, and coming to power factor improvement. Power factor in improvement is nothing but it is the ratio of real power and apparent power. It reflects the efficiency of electrical energy usage usage in the motor. A power factor choose to 1 indicates optimal performance. So here is the basic circuit diagram of power factor improvement. So it is based upon the capacitor and synchronous motor and phase advancer. Here phase advancer is nothing but phase advancer is the one of the equipment which was which it would be connected to external. Here is synchronous motor, that is RYB, that means red, yellow, blue, which is connected to three-phase load. Again, it consists of RYB. Here we can call it as three-phase supply. Generally, synchronous motors will work under the AC current condition and as well as three-phase supply. Here, three-phase supply will leads to RYB. And coming to the next slide, equation of power factor. The power factor is expressed in the form of P by S. P is nothing but real power and S is nothing but apparent power. Here, yes, yes. In the below sentence, sorry. P can be called it as real power in watts and S can be called it as apparent power in volt amperes. A higher power factor signifies the less wasted energy in the system. By observing this graph, we can say that where current flows to the voltage is very constant, but current flows very inconsistently. Thereby, we can say that there are the three types of power factor, that is leading power factor, lagging power factor, and unity power factor. Well, unity power factor, which consists only one. Well, and coming to the next slide, what are the effects of current and power factor? In previous slide, we have told that there are the three types of power factor. There are lagging and leading. In that, we are discussing about lagging versus leading. So how can we know that what's the lagging and what's the leading? Yes, increase the current can lead to improved torque and output. Where there is when there is an increment in current flows, then we can see that improved torque output. However, excessive current may result in lower power factor. Managing the current levels is vital for maintaining an optimal power factor. So by seeing this graph, we can say that which is lagging and which is leading, which is uh, which is leading and which is useful. Right? By observing this graph, and the current is when current is initial and voltage is also initial, then we can call it as a leading. And when there is a voltage in backward and for current in frontward, we can see that lagging. Yes. By the resulting graph would be like here intersects at 180, 180 torque. Here power factor formula is to that 0 is equals to 1 for unity power factor, and coming to leading power factor is equals to cos phi. I think they have got a knowledge about in P.venkat, that is basic electrical and electronics engineering. In that you have known about what's the basic principles of power factor and so on. And coming to the relationship between the power factor and current. So what's the relationship between the power factor and current? By seeing this circuit diagram, we can see that here is the voltage level, that is 230 volts, and a resistor, that is 60 ohms. Power factor is influenced by the type of load connected to the motor. Well, when there is a load, we can see that intermittent power factors. Inductive loads tends to lower the power factor due to the lagging current, and appropriate current level helps to correct the power factor. So this is the relationship between the power factor and current. So here you will get it out. So what's the meaning of power factor and what's the meaning of current? Well, current is nothing but where a current, the flowing of electrons in a conductor is known as current. And coming to power factor, it is the ratio of real power and apparent power, which was mathematically can be represented as P by S. Yes. And coming to voltage and current in synchronous motor. The voltage across the motor affects the current drawn. With the help of Ohm's law, we get V is equals to VIR, which helps relate and voltage, current, and resistance. By seeing this graph, we have the so much relation between and field current and open circuit voltage and short circuit voltage. Well, by seeing this graph here, this is the HCC, that means short circuit characteristics, and OCC is nothing but open circuit characteristics. So this graph is drawn between the field current and as well as open circuit voltage. Here there is a rated voltage and rated current, rated current can be represented as IA and rated voltage can be represented as VT. Yes. And coming to reactive power in synchronous motor, how does it relate to? Well, reactive power is the power that oscillates between source and load. That means it oscillates is nothing but it could be like a AC type signal. It is very necessary. It is very necessary for establishing the electric and magnetic fields. Synchronous motor can supply the reactive power to improve the power factor. So by improving the power factor, there is a one method. We can call it as simplification of reactive power in synchronous motors. Well, here this is the here this is the basic example of how does a power factor can be improved. A three-phase delta source load system has a complex power on the load 350. This load has a 150 volts VA. This load is a voltage across the 75 degrees and 50 degrees swings and oscillates at a frequency of 30 Hz. So this is the basic example. And coming to the next slide, equation for a reactive power. Well, average reactive power. So what's this main agenda is to be that? So what's the equation for reactive power? Whereby reactive power is calculated by using Q is equals to V and your therefore sin theta is equals to QV. So this is the equation for reactive power. And coming to power factor correction techniques, how we can correct the power factor? How we can correct the power factor? Capacitors can be added to the system to improve the power factor. To improve the power factor, here there is a basic method that is capacitors. Well, what do you mean by capacitor? Capacitor is a type of it is the type of passive element which stores the current in the form of electrostatic field. Well, yes, synchronous condensers can also be utilized for the dynamic correction. Both methods will help reduce the losses and increase the efficiency. And coming to consequences of poor power factor. So what will happen if there is no any improvement in power factor? So what it will happen? The low power factor can lead to increased power bills and penalties. If there is a low power factor, it can be lead to increased power consumption. It leads to penalties. It can be also cause overheating and reduce the lifespan of the motor. By maintaining an optimal power factor is very essential for operational efficiency. Efficiency is nothing but output by input. And coming to a calculation of percentage of efficiency, that is output by input into 100. So these are the consequences of poor power factor. So this is the basic diagram of power factor. And coming to monitoring of the power factor and current, how we can monitor? Well, continuous monitoring helps identify the fluctuations in performance. And instruments such as power analyzers and provide in real-time data. Regular assessments can prevent issues related to the current and power factor. So this is the monitoring of the power factor and current. And coming to case studies of power factor and voltage. So this is the very it would helps like a reference purpose. Industrial power factor correction manufacturing facilities. Case studies demonstrate the impact of power factor correction in the various industries. Improvements in efficiency are often quantified and in reduced operational costs. Real world examples like highlighting the benefits of maintaining optimal current levels. And coming to conclusion of this whole entire presentation, current and power factor are very critical for the performance and of synchronous motors. Understanding the relationship can enhance the efficiency and reduce cost. By implementing the corrective measures, ensures longevity and reliability in operation. Okay. So, thanking one another for giving this a wonderful opportunity. Thank you.